Okay, so we're going to get started. I have two people. I have myself and Orange Juice, who tomorrow morning, I can't wait to hear who Orange Juice is. I do have Freddie here. He is consistently trying to scare me and bother me. And right now he's using the camera as his nose and his eyes are above it, but such is life. So hopefully people are going to eClass and clicking the link to come into this. If you do come in, just add questions. And otherwise, I'm just going to start going through all of our information. So the main thing you have to do is there are 2 or 3 questions that relate to definitions. So I'm first going to go over this packet real quickly and highlight the most salient points, the points you really need to know. And then from there, we'll look at some questions in the review packet that you got today. So first and foremost, some of the things you should know are a point. Yes, a point right here. I have too many things going on my paper. When we talk about a point, we're talking about a specific location. That point doesn't have any distance or measurement. It just shows us this is where it is. So if you think about today, for example, in our extensions activity, where we drawing the point that was the center of rotation, it couldn't tell us anything unless we drew that other ray to go out from it. If we come down here, we've got a line. Qualities about a line are they are infinite. It goes on forever. You might have it labeled as like line L, or you might have it labeled as 2 points that are on that same line. Then we've got parallel lines. Parallel lines are located right here. The main thing to think about for parallel lines is you want to make sure that they are located in the same plane and that they never intersect. We're also going to learn later how parallel lines have the same slope or congruent slopes. And the coolest thing is, and you've learned this with translations, that because parallel lines never intersect, the distance between the parallel lines is always going to be the same. It's not if this is 5 here, that means this is 5 here. And if these lines continued on forever, that distance between the two would be 5. Perpendicular lines are different. Their slopes are opposite reciprocals. Again, that's going to come more into play when we go into Unit 5, which is like next March-ish. Perpendicular lines have right angles. Also with that, you're going to come into it with trigonometry. The main thing to think about perpendicular lines is the distance from the point down. That is your the shortest distance. So in class, I drew a line like this, and I drew a point, and I asked you, okay, what's the shortest distance between that point and the line? And we said simply that it was going straight down and forming a right angle. That is going to be your shortest distance. That's actually called the altitude. In terms of a line segment, other things to think about for a line segment is the line segment is 2 endpoints and all the points in between. So it's not just this measurement. It's not just the distance between 2 points. It's also those 2 points. So you have to mention that the line segment includes the end points. The angle is 2 rays coming from a common point. The circle is the set of all points from a given point. And then arc length, we're not there yet, but that is what we're going to talk about in the circles unit, which is Unit 4. Things to think about for, I keep forgetting that I'm using this. Things to think about for transformations in general are make sure that you consider that transformations are the movement of objects and shapes. We have a pre-image and we have an image, and that is the concept of the transformations. The pre-image is always the first image. The image is always the second. And don't forget that we have A prime, B prime, and C prime. Now, some important things to remember is that they are also corresponding. So what I mean by that is that A maps to A prime, B maps to B prime, and C maps to C prime. Other things to think about is because they map, as long as it's one of our big three transformations, which are isometries, rotation, reflection, translation, then basically, I don't know where my camera went. Then what you're going to do is, I do want to know where my camera is. Oh, there we are. Then what you want to do is AB is congruent to A prime, B prime. And BC is congruent to B prime, C prime. So we kind of went over that earlier today. Excellent. Yay, we have another person. Welcome. In terms of rigid motions, I already referenced this. This is kind of our big ones that we talk about. We have our translations, our reflections, and our rotations. Translations slide. We learned today that when translations slide, we know that the distance has to be equal movements. That was what you were doing when you were doing your translations. You were measuring what's the distance between A and A prime. That's the same as the distance between B and B prime, which is the same as the distance between C and C prime. We also learned when you do translations, they have parallel movement. Okay, reflections flip. Whenever we do reflections, we have to make sure it's over the perpendicular bisector. And then, of course, rotations turn around a given angle. Over here for translations, most of this I went over already. Again, pay attention to the rules. And then this more things to know in terms of those lines being congruent as you go. For reflections, there are rules that you can remember, but we also did the hand thing that every time you do a reflection of 90 degrees, the coordinates flip-flop and you take the sign of the quadrant that the point lands in. We also talked about clockwise versus counterclockwise. So if it doesn't give you a degree rotation, if it just says 90 degrees or 270 degrees, you know you're always going to go into a counterclockwise direction. However, if it does say clockwise, then you know you're going to go in a clockwise direction. But there are the rules there if you are interested in memorizing them, and there's some examples. And I just talked about rotations on the reflections page. Here's the rules for rotations in terms of the flipping signs. I'm sorry. The reflections, basically, we counted boxes. So in this example here, you can see that I counted going down one line. This point stayed on it. This went down 2. This went down 2. If you have a diagonal line like y equals x, then we count diagonally to map our points from there. So I'm not going to dwell a whole lot of time on here because you should be able to use your time wisely and look it up, but it is there if you need it. Okay, lines of symmetry, some really cool things to think about for lines of symmetry. We pretty much talked about lines of symmetry, point symmetry, and rotational symmetry. Really for our test, you're going to need line symmetry and rotational symmetry. Point symmetry we just described as having a spin of 180 degrees. So we've got our line symmetry here that allows us to map the image onto itself if we fold on that line. So some of you did the reflections activity on the back of our investigation today. So you traced it in patty paper and then you folded the patty paper on the line. So that's kind of what we're talking about. Some important things to think about. Not every shape is going to have diagonal. So if you think of a rectangle does not have diagonal lines of symmetry, because if we folded on this line, we'd end up getting this point somewhere up here and it wouldn't map appropriately. So even with the parallelogram, that's another example. If you think of a slanted parallelogram, you can't fold a parallelogram with a line of symmetry. You just can't do it. Now, if it's a special parallelogram like a square, then you could do it. But in general, you just have to pick, if I fold it in half, is it going to map perfectly? This we didn't talk about a whole lot, but you do need to know it. We did some examples for one day, is the whole rotational symmetry. When you have rotational symmetry, what you're going to want to do is you want to make sure that you take 360 degrees and then you are going to divide that by the number of sides. So this, for example, is not a perfect octagon, but I could potentially draw an octagon around it. If I connect these vertices, you get a perfect octagon. So that allowed me to use the rule of 360 divided by 8. Here, all these sides are the same. It's a square, 360 divided by 4, hexagon, pentagon, etc. Then what we did is we said, okay, well, if we do 360 divided by 4, that gives us 90 degrees. So that means every 90 degrees, it's going to rotate. So if you have 90, then it rotates again. That's going to be 180. Then it rotates again. Then it's going to be 270. So that's the whole premise of rotation, is you want to be able to think, okay, I know the smallest degree of rotation. And a hint on your test, it's not going to be the smallest degree of rotation. You're going to have to do multiples in order to discover the correct answer. answer. I should have muted my mic. I'm sorry. So Here I did 60 plus 60, got 120, 180, etc. Hold on one second. I am rocking a tickle. We are not yet on numbers. Okay, so then, oh my gosh, I'm so sorry. Hopefully I'm back. We'll see. Okay. Spotting the transformations. This is the hardest one. You have to pay attention to the points. And so what I mean by that is here, we look at this transformation. It could be multiple things because it doesn't tell us A prime, B prime, or C prime. You're going to have to review and see what those primes are, and that's going to help you determine what it is. If it was labeled like here, A prime, B prime, C prime, we know it's a translation because this B maps to B prime, C maps to C prime, so it has to be a translation. Here, look at where C and C prime is. Now we know it's got to be a line of reflection. So my main thing is make sure you pay attention to the coordinates. Wow, because that's going to really make a difference. Okay. Next. Series of transformations, still same thing. Look at the coordinates, see what you have to do. Okay, now we're going to go to this. Okay, so I'm only going to cover some high-level stuff, and then we'll kind of move through. You will have to know definitions. So the major definition between parallel and perpendicular, I kind of talked about on slide 1, is parallel lines never intersect. Woo! Parallel lines, the symbol for parallel is this. The symbol for perpendicular is upside down T. So basically, parallel lines never intersect. The distance between the two parallel lines is always going to be the same. Okay, so for example, if we look at, yay, another person. Okay, so if we think of, hi Theo, just turn off your microphone and you're good. Okay, so if we think about parallel lines, and we look at this pad of paper, this line here and this line here will never intersect. Because they're not going to intersect, they're parallel. We also know that because they're parallel, the distance between this line and this line is exactly the same. Same thing here. The distance between this edge and this edge is going to be exactly the same because these lines are parallel. This right here, this corner is perpendicular. Perpendicular lines intersect, but not only do they intersect at right angles. And as I said in the notes, you want to make sure that if you have a random point, the shortest distance from a single point to a straight line is perpendicular. Okay, so in this case, the answer is going to be choice C. Parallel lines do not intersect, perpendicular lines do not intersect, and also you can mention that perpendicular lines form right angles. Looking at this next one, we're not going to really, you won't necessarily need this bottom one yet for your test, so we're going to skip it. Here where it talks about parallel, identify two line segments that are, appear to be parallel. Again, just extending the line, where is it going to be for us to see anything? And if we extend the line, we know that AB is right here and FA is here. Well, they clearly intersect, so that's not parallel. BG is this long line again. KF is here. Again, those intersect. BG, JC, those intersect. So you're really looking at JC and DH, and those, again, distances are going to be the same. In terms of identifying appropriate ways, and again, if you have any questions, please, please, please stop me. In terms of identifying appropriate ways for labeling points, when it says that identify all the appropriate ways to refer to the figure formed by points YZ and all the points in between, that again is emphasizing a line segment. When you have a line segment, you're not just talking about the distance between the points, you are also talking about the specific points. And that's what we have here. So we have things like segment YZ. That is correct way of saying it. Line segment YZ. B actually isn't one of them. I haven't taught it to you directly yet. You're going to learn it more in the Unit 2B. This is actually what we're going to do when we talk about measurement. So if they gave us this distance was 5, that would tell us that the measurement is 5. It doesn't talk about the actual segment. It just talks about the measurement. So far we have choice A. Choice C with the line over it, that's accurate. D is not accurate because that references if it was a line that went on forever. E is also not correct because that represents a line that goes on forever. F is also not correct because that has one side that goes on forever. This last one, ZY, is correct because it doesn't matter the order if you're talking about the same line. I'm not going to go over this too much, but I will say 2 questions of your test relate to this section right here. So I highly recommend you know the section. 2 questions of your test relate to it. Next, you don't have to worry about circles on your test. Not that you don't have to still do it, but number 10 won't be on your test. 11 will kind of be in a way. So you just remember perpendicular is the 90 degrees, the right angles. Number 12 is actually an extension problem. So number 12 will not be on your test. So for our purposes in terms of studying, you don't have to worry about number 12. Next. Okay, now we're going to transition to the next AKS. This relates specifically with the ability to do translations. Doing a translations, at least one of the questions on your test relates to translations. We also have, of course, rotations and reflections. So here it says 12 units to the right and 7 units down. So just remember, I say just count. You could also add, but 7 units to the right. Woo, that's too big. I'm sorry, 5 units to the right, 1, 2, 3, 4, 5, and then 7 units down, 1, 2, 3, 4, 5, 6, 7. And in this case, it's asking for only vertex C. So you would have to do that for vertex C, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. And that would be our point, 2, -6. Here, you have to describe what happens. Here's a hint. If you have to describe something that happens and you're like, I have no idea what happens, I don't know the rule, just pick points and plug them into the equation and see what happens. So for example, if I pick this point right here, I know the coordinates of this point are -2, 4, and I can tell that it maps here to +2, -4. So I think, well, what happened between -2 and +2? 2 possible things happened. One is I added 4, and the other is I switched signs. For my y value, I'm sorry, I subtracted 4. For my y value, I subtracted 8, but I also just switched the signs. It went from -2 to +2. It went from -4 to +4. So I can tell that there's some kind of thing that happened. The other thing I can tell is that it's facing a different way. And because it's facing a different way, I know it's not going to be a translation. So I'm left between A and C. Well, here, this tells me my -x. Well, that's exactly what happened. Here I was at -2. Now I'm at +2. So my answer is solution A. It wouldn't be this one because if it was this one, it would be -4, +2. And it didn't switch. So again, the main thing to think about, you will have at least 2 questions that you have to come up with a rule on your test. Worst case scenario, pick a couple points that are on the pre-image and a couple points on the image and plug them into the equations to see what you get. And that's the easiest way I can think about to do this particular problem. You will have one question on your test which talks about rigid motion, isometries, and preserving distance and angle measure. This right here, this section down here, is the question that will help you remember to do that. Remember, isometry, rigid motion, and preserving distance and angle measure. Those are all synonyms. Okay? We've got translations, dilations, reflections, and rotations are all the ones. Yep, perfect. We got another person. Yay. Hi.
I'm not even signing as my own account.
You're here.
Oh
Just
my
go put
gosh.
yourself on mute. You're good. Yay, you found us. Just go ahead and mute yourself, sweetie.
Are you able to get it?
Yeah,
You're here. Just mute.
I can't find it.
Let's see. I don't know if I can mute you. I can't mute you. Okay, perfect. Okay, so going back. Welcome, welcome, welcome. Okay, so going back, those are your main thing you have to pay attention to. Translations, dilations, or I'm sorry, not dilations. Dilations is the only one that doesn't preserve angle measure and distance. So it would not be choice C. So it would be A, B, and D. Okay, so if you just joined us, we are on page 3 of the packet. And that's what we're kind of moving through. Here, for this one, you will need to have some kind of idea of what happens. So you can have some idea of what happens by knowing the rules and memorizing them, or you can have it in terms of finding the coordinates and, like I showed you before, figuring out what happens between the coordinates. But you will have something like this that you're going to have to do on your test. Next. Down here for the constructed response, you won't have anything like this. This deals with skewing images. So for the purposes of our test, we can cross off number 9 on page 4. That's not going to be on your test. 10, you will have to do something like this. You will have a different formula, though. You won't have one that has it as a skew. You will have an activity like 11, where you get a set of points. You're actually going to get a triangle, and from there there's a series of transformations that you have to do, and then you have to do some almost exactly like this one. I don't know why I made that so dark, but you're going to have to. Number 11 is a perfect example of a question that you're going to have on your test. It's like a 3-part question, very similar to number 11, where you're going to do multiple transformations and then come up with the one rule that's going to end up working for you. As a reminder that we did talk about this briefly in class, let's look at this one together. Here we have -3, 5. It tells us this is the rule. On your test, you're going to have a triangle, so you're going to have to do it as a triangle. This says take the opposite of x, so the opposite of -3 is +3. Here's +5. This says to take the opposite, so now we've got -5. Then it says what type of transformation is this, where we changed it. Well, hopefully you remember, it's kind of like we do, let me log off here. Remember how we did 3, 5, and then we flip 5, 3, and then we flip 3, 5. So this one thing is a rotation of 180 degrees. And then it says it wants us to find the image. So now that we have our coordinates that we've got here in part A, we're going to use those coordinates to do this next transformation. So that's when we're going to go here and subtract 2. So if I started at 3, -5, and it tells me subtract 2 from the x and add 4 to the y. Well, 3 minus 2 is 1. -5 plus 4 is -1. And that's going to be my new point. So now that I have that new point, that's going to allow me to go and say, it says, how did you get from that first point over to the next one? Well, this particular problem is super easy because it's only 1 point. So because it's only 1 point, you don't necessarily have to worry about doing a rotation or anything like that. You can just do a simple translation. On your test, though, you will have to do you will have to incorporate another level, like the rotation. So just kind of pay attention. The other thing you have to pay attention to is what it asks you. Here it asks us to map A double prime to A. So if we start at 1, how do we get to 3? If we start at -1, how do we get to -5? So if I'm at 1 and I'm going to 3, well, I know I need to add 2. If I'm at -1 and I'm going to -5, I know I have to subtract 4. Now, what I haven't taught you yet, which I am going to show you tomorrow, is the concept of vectors. We talked about that you could see it written like this. You can also see the translation written like this with little like Pac-Mans against it. So this means the same thing, 2, -4. That's called a vector. That means the same thing. But we'll talk more about that in school tomorrow. Horizontal stretch, not on your test. So we'll cross that out. Next, 13. This one talks about which transformations will map the figure onto itself. If you remember the activity that we did on Friday where we cut all those shapes out and we were gluing them and we had to make congruent shapes and we folded them and we drew lines, that's this activity. Okay? So here it says determine which of the following transforms our figure. Okay, this 79 degrees there is only to let you know that it's not a rectangle, because if it was a rectangle, it would impact us a little bit more. You don't know this yet, but you will know that in our next unit, the angles, that 2 angles on the same side of a parallelogram are supplementary. They're equal to 180. So if I do 180 minus 72, I get 108. So I know this is 108 degrees. The only reason why that is a little bit relevant is because we know that we can't just turn it 90 degrees and it'll look the same, because right now we have an obtuse angle in that top corner. When we rotate it, we're going to have the acute angle in the top corner, which is essentially what we don't want. So because of that, we know we can't do a rotation of 90 degrees. Now we have, can we do a reflection on a vertical line? There is no vertical line, because these degrees measures are not the same, that we can use to fold it. So the answer is no for here. And same thing for a horizontal line. There is no horizontal line that'll let us fold that shape. So the only thing it could be is a 180-degree rotation. A square is a little bit different. A square is has 4 sides. And not only does it have 4 sides that are congruent, it also has 4 angles that are congruent. And because those 4 angles are congruent, that allows us to have more lines of symmetry. So we have a line of symmetry down the center, going down here, going across, and going at the diagonal. Those are all lines of symmetry for a square, because all the angles are the same and all of the sides are the same. The regular polygon, we talked about this already. This is an octagon. Remember 360 divided by the number of sides, because this is an octagon, right? 1, 2, 3, 4, 5, 6. Yep. 8 sides. There's 360 degrees in a circle. So we've got our 360 degrees in a circle. We're going to divide that by 8, and that's going to give us every degree that we can turn it. So 360 divided by 8, only because I've done this forever, is 45 degrees. So every 45 degrees that we turn it, it's going to map onto itself. So we've got 45. 45 plus 45 is 90. Plus 45 again gives you 135. Plus 45 again gives you 180. And then you get the idea. It's very likely on your test that it won't be the first answer, because if it was the first answer in 45 degrees, it wouldn't be checking your knowledge of keep spinning the shape. So you might have to spin the shape several times to do it. The answer to number 3 is choice C. Next, we have here going down, line symmetry, rotational symmetry, both. I will do some of these. A rectangle. I don't remember if a rectangle specifically is on your test, but a rectangle does have line symmetry. And it also has rotational symmetry, 180 degrees divided by the number of sides. So that would be if it was a square, but it's not a square, so we have to divide by the extra 2. So really there's only 180 degrees for that. So a rectangle actually has both. An isosceles trapezoid, remember, looks like this, where you have one short and one long side, and then these sides are the same here. The only way that you can divide an isosceles trapezoid is right down the middle. You cannot rotate it. You cannot reflect it other than that one line of symmetry. There's no rotational symmetry. It's literally just that one line going down. There's no diagonal, no across, one line going down. Regular octagon, we've kind of talked about before already. This is not going to look perfect, but there's our octagon. We've got straight down and across and diagonally every single flat side. And then we also have it through every connecting vertice, which is kind of hard here, but that will give you 8 different lines of symmetry. It also has rotational symmetry, which we saw on the other problem. A scalene triangle does not have line symmetry. It does not have rotational symmetry because it's scalene. An isosceles triangle, you could do line symmetry. A parallelogram, we already talked about. A parallelogram is rotational symmetry of 180 degrees, but it does not have line symmetry. You will get a question kind of like this on your test, again, where you're given a shape and you have to determine, there's multiple choice answers and you have to determine which of them work out for the problem. I'm not going to keep talking symmetry because I think we've pretty much covered everything you're going to need to know. So I'm going to skip that page. Okay, now we are on page GCO4. Okay, what is the definition of a reflection of a preimage point P across line M? Hello, welcome, welcome. You just have to mute your camera and your phone. Yay, another person found us. This is great. I'm sorry it's been so confusing. Okay, so what is the definition of a reflection of a preimage point across line M? Okay, so here's our, let's just draw it. We know we have a point P and we know we have a line M. So if a point P is on line M, if it's on it, then M is the perpendicular bisector of PP prime. All right, I really don't want to spend a whole time talking about this, but that's actually not true. Because, yeah, that's not going to be true. We're going to skip it because that's not going to be on your test. Will you need to know it? Yes, but not for Friday. Definition of a translation by a vector. A vector is on your test, but again, we're not going to really talk about that in this way. This is way harder than what your test is, or way different. Same thing for number 3, you won't need to know. Number 4, you don't need to know. Yep, this is all good stuff that are extensions, but none of it explicitly is going to be on your test. So let's just, actually, we'll just skip all over that. We don't need that. Let's go to this one. GCO5. Okay, so what are the vertices of the image? After the translation, you will have something like this. I don't think I have to go over translations anymore. We just have to remember that we are going to add or subtract. Remember, X's go across, Y's go up and down. Okay. The clockwise rotation, let's demonstrate this real quick. This says actually counterclockwise. So I know this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So when it says counterclockwise, it's going in the direction of the quadrant labels. This point here is 1, 1. So we've got our 1, 1. So now we just flip it, 1, 1 again. And so that's where this point's going to be, right here. This point here is 5, 1. So if we're at -5, 1, we're rotating at 9 degrees. Now we know we've got 1, 5. So I'm going to go over 1, down 5. Come on, pen. Here we've got 1, 4. So we're looking at 4, 1. And then we can draw the rest of our rectangle. So that is going to be the rotation, and then you would just select whichever the correct answer is. So we've got -1, 1, -1, 5, -4, 1, -4, 5. So choice D would be the correct answer for that question. Next, let's see. Reflected across the x-axis, you will have something like this too. You can know the rule. You also will have 2 small grids on your test on the, like, that's kind of like scrap paper that you can use to kind of like draw and sketch out your different shapes. Remember, for the x-axis, when you do the reflection though, if we have it at, let's look at this point specifically, 1, 5. We know if we're reflecting over x, we're going to count down. So it's 5 to the line and then 5 more down. So this point will stay positive. The x stays the same. The y switches signs. So you're looking at this choice or choice B. Okay, next. Here again, it's a translation, which we're not going to talk about. This one we're not going to talk about. You don't need to know how to do this. This one you can know. This is a little bit challenging. There is one challenging question on your test. I'm not going to necessarily go this. Let's see. Yep, this one is a little bit more extensive than what you're going to end up seeing on your test. So on the test, the most that you have to do is like the one that I showed you earlier, which was 2 transformations. And then you have to say, how did I go from the first one to the last one? So that's similar to the question we went over earlier. Is there a sequence of rigid motions that map ABC to MNP? Yes, there's something like that. You just have to kind of pay attention to what the points look like. So it's pretty obvious that point B is our right angle. So that's going to have to map to N. So we have to think, how can we get from -2, 4 to -2? What could happen? And because it says a sequence, maybe you might, in this case, I would probably reflect it first, and then I would translate it down. But there's not going to be many of them. There's only going to be a couple of them, but there will be times that you'll have to discover what you're going to do. The main thing for reflections is that perpendicular bisector. So we're going to measure here to here, and then that same distance on the other side. And then here to here, same distance on the other side. And then here to here, and the same distance on the other side. Like that. Next, we've got this one, which again, you pretty much have already done. Draw the image, translate it, and then explain your reasoning. I think I've kind of hit that over. So before we go, that's pretty much the highlights. Is there anything that anyone wants me to cover? If you do, just go ahead and type a message if you see on my screen here. Up here where it says people and then it says chat. So if you click on chat, you can type a message and I will wait while you do that. Okay, so if you're good, can you just give me a thumbs up or all good? So we're good. Yay, Alpha Naive, you read my mind. Anyone else have anything that we're all good? Okay, the cat emoji is fantastic. All right, I guess what we're going to do, thank you, is perfect, thank you. I'm going to save this video and I will upload it to eClass and YouTube so you guys can watch it if you came in late. I am sorry. Tomorrow I will teach you how we're going to access this for everyone else because it was a surprise. I spent an hour trying to get YouTube to work. Oh, we have another person. Welcome, new person. We are actually just finishing, but I'm going to post the video to YouTube so that you can watch it again because we had some technical difficulties earlier. And I will see everyone tomorrow in class if you're one of my students. So this is it. Thank you so much. We'll catch you guys later. Bye. Yay. So.